Hello everyone, let's discuss very most important concept of transformer, that is EMF equation of transformer. So we all know that the EMF induced in case of transformer is statically induced EMF, right? So statical induced EMF, which is nothing but self-induced EMF and mutual induced EMF, which is what is the notation for us? For E self, which is nothing but E1, for E mutual, which is nothing but E2. So we have to derive the equation for E1 and E2, right? So what is the formula for? First I would like to derive E1 minus N d5 by dt, right? Where phi, which is nothing but what? Phi m sin omega t. Here I am taken phi m sin omega t as reference. Flux is taken as reference, that is let us take this is flux. So obviously EMF lags flux by 90 degrees, right? So from this position to this position, so simply is the EMF. This is what? EMF. And what about flux? This is flux. When it is 0, this is maximum, right? This is the waveform for this equation. Here I am taken flux as reference. Therefore substitute this value. E1 should be equals to minus N1 E by dt of phi m sin omega t, right? Which is equals to minus N1 phi m omega cos omega t, right? So which is equals to what? In order to eliminate this sign, N1 phi m omega sin omega t minus 90. So from this waveform, when we are going to get the maximum value of EMF, this is the maximum value of EMF, right? E max. When we are going to get maximum value of EMF, when flux is at pi, right? Because we have taken flux as reference. When the angle is 180 degrees, obviously at this instant only we are going to get the maximum flux, right? Therefore at omega t, right? At omega t, which is equals to 180 degrees, we are going to get maximum flux, right? E1 max. Therefore now it is E1 max, which is equals to what? N1 phi m omega sin 180 minus 90, which is equals to what? N1 phi m omega E1 max. So this is the maximum value of EMF, that is phi n omega, or you can write, wait, with respect to frequency we have to write. So E1 max should be equals to what? Phi n1, where omega is nothing but what? 2 pi f. 2 pi f. We can write like this. So from this, what is the RMS value of EMF? E1 RMS. We all know that E1 max by root 2, which is equals to what? Phi n1 2 pi f by root 2. So from this we are going to get the value of E1 RMS, which is equals to what? 2 pi by root 2 into pi m n1 f. So what is the value of 2 pi by root 2? Which is equals to 4.44 pi m number of turns of primary into frequency. So this is the EMF equation of a transformer E1 RMS, which is equal to, this is RMS value. This is what? Maximum value. This is RMS value. 4.44 pi NF, simply pi N1 F. Right? Where pi m is what? Where pi m, which is equals to B into A, maximum value of flux density into area, where phi m is nothing but B into A. Therefore, we can write E1 RMS, or simply we can write E1. By default, E1 is nothing but RMS quantity, 4.44 BMA N1 F. This is the EMF equation of a transformer. E1 is nothing but what? Self-induced EMF. So similarly, same equation is there. Similarly, for E2, which is equals to same amount of pi m. Now it is N2 F, which is equals to 4.44 BMA N2F. If we have any doubt, same derivation we have to follow. Minus n d phi, minus n2 d phi by dt. Phi is equals to pi m sin omega t. Right? Same derivation as E1. Right? So we have EMF equation. What is the summary? Or we can write some observations. Observations based on EMF equation. Right? So we all know that first observation, first one is what? E1, which is equals to what? Which is nothing but RMS value of EMF, 4.44 pi N1 F, right? Which is nothing but E1, which is equals to, we can write 4.44 BA N1 F. Like that, E2 should be equals to what? 4.44 pi N2, which is nothing but 4.44 BA N2F. Right? Let us consider this is equation 1, this is equation 2. So we have to write EMF per turn, which is nothing but what? E1 by N1. So from this equation, EMF per turn, E1 by N1 should be equals to what? 4.44 pi F, right? Like that, E2 by N2, which is nothing but what? 4.44 pi F. So from these two equations, From this two equation, what is observation? E1 by N1 which is equals to E2 by N2, right? E1 by N1, this value should be equals to this value. So E1 by N1 should be equals to E2 by N2, which is nothing but E1 by N1 should be equals to E2 by N2. So from this we can write E1 by E2 should be equals to N1 by N2, which is nothing but this ratio is called turns ratio. This is very most important. E1 by E2 should be equals to N1 by N2, which is equals to turns ratio. It is N1 by N2, not N2 by N1, which is nothing but E1 by E2. Don't confuse at all. When turns ratio is given, which is nothing but E1 by E2 or N1 by N2. So like that, the reciprocal of turns ratio is transformation ratio. That is transformation ratio which is equals to 1 by turns ratio. Let us say T. We can write T which is equals to 1 by K. 1 by K. That is, this is transformation ratio, this is turns ratio, right? So transformation ratio T should be equals to E2 by E1 because reciprocal of turns ratio. Turns ratio, first you have to write with respect to turns. N1 by N2 is equals to E1 by E2. This is very most important. Don't confuse with these terms, whether it is transformation ratio or turns ratio. Don't confuse at all. Just remember this turns ratio, that is N1 by N2 which is equals to E1 by E2. And very most important concept here, transformation ratio is always in terms of induced EMFs only, induced EMFs only, but not in terms of terminal voltages. What is the reason? So for every machine we have a nameplate details. For every machine we have a nameplate details. So in that nameplate details, these EMFs are the given data is nothing but in terms of induced EMF only, not in terms of terminal not in terms of terminal voltages. Or you can write what is the reason? What is the reason? Nameplate details are provided with induced EMFs only. That's why transformation ratio is always in terms of induced EMFs. For every machine, the nameplate details which are having induced EMFs only. Okay, for example, what is the example? The nameplate details on transformer is 400 by 200 volts transformer. Then tell me, what is the transformation ratio? What is transformer? Transformer. So from this we can write E2 by E1, which is equals to 400 by 200 volts transformer. So this 200 volts comes under self-induced EMF. This 400 volts is what? Mutual induced EMF. Therefore, what is turns ratio? Turns ratio K, which is equals to E1 by E2, which is equals to N1 by N2, which is equals to what? 200 by 400, which is nothing but 1 by 2. What is transformation ratio? T, which is equals to 400 by 2. Transformation ratio is 2. So these are the induced EMFs in the transformer. These are the mentioned details on nameplate. This is the first observation. Second observation. What is second observation? This is very most important. We all know that E1 should be equals to E2 should be equals to 4.44 pi, whether it is N or we can say same number of turns. Okay, 4.44 can write BANF for same terms. Okay, don't bother about the number of turns. Here the point is different than the number of turns. So once this is very most, once transformer is manufactured, which one is constant? When transformer is manufactured, number of turns and area are constant, but during operation of transformer, EMF and frequency are varied. This is very most important. Before the manufacturing, you can be able to vary number of turns and area, but once the transformer is manufactured, number of turns and area of the transformer is constant. Only during operation the induced EMF and frequency are variable. EMF and frequency are variable. So from this number of turns is constant, that is, let us say these two are constant, only the remaining terms are what? Flux density and frequency. So from this we can write B, which is proportional to B is proportional to what? Induced EMF by frequency, right? From this equation, see, B is proportional to EMF is proportional to what? B into F. From this, B is proportional to E by F, right? So from this, B proportional to E1 by F, which is proportional to E1 is responsible for, or a supply voltage is responsible for induced EMF, that is finally, which in turn B proportional to V1 by F. B proportional to V1 by V proportional to V1 by F. This is very most important concept. V proportional to V1 by F. So in order to maintain constant flux density, V1 by F should be maintained as constant, right? So what will happen if we are not providing constant flux density? So desirable quantity is nothing but we have to maintain constant flux density. So what will happen if we are not maintaining constant flux density? For that, example 1. So let us take, what is the equation? V1 by F. Now I would like to take one example. Here the supply voltage is reduced to half and the frequency is reduced to half. So therefore P proportional to V1 by F, which is proportional to V by 2 by F by 2. So obviously which is proportional to V by F. So B, which is equals to constant, that is no change, right? Because the supply voltage is reduced to half, like that frequency is reduced to half. Like that, there is no change in the flux density, no problem. Then coming to second example, example 2. These observations are very most important. Please listen carefully. Now the supply voltage is reduced to half and the frequency is doubled. Here the decreases, frequency increases. Then what will happen? We all know that B proportional to V1 by F, which is proportional to V by 2 into 2F, which is proportional to V by 4F, that is B proportional to 1 by 4 into V by F, that is B proportional to 1 by 4th of B previous, right? Previous value of flux density. That is, therefore, what is the statement here? B will reduce 1 by 4th value. The flux density will reduce to 1 by 4th value if the frequency is double and the supply voltage is reduced to half. That is the case. For this case, the frequency, for this case, we have 1 by 4th of the flux density. Now, next example. Example 3. So during operation of transformer, applied voltage, that is V1, is maintained as constant, clear, and frequency is reduced to below rated value. So for this case, what is that case? Supply voltage is constant, but coming to frequency below rated value. So obviously, what about flux density? P proportional to V1 by F. Here the frequency reduced to, or it is below rated value, right? So what is that meaning? Frequency is reduces. If frequency reduces, what about flux? That is, if frequency is far less than F rated, obviously the flux density is increases more and more. Flux density increases more and more. So obviously, what will happen? What is the consequence? Then transformer goes into deep saturation. This is the unwanted operation. If we are reducing the frequency, by reducing the frequency below rated value, obviously we are going to get the increasing value of flux density. If we have more value of flux density, then the transformer core goes into deep saturation. This is unwanted for us, unwanted thing for the operation. So never reduce only frequency with keeping supply voltage is constant. So for satisfactory operation, V1 and frequency should be varied proportionally. So we can write that. What is that point? Therefore, or we can write here. Therefore, so never reduce only frequency by keeping supply voltage constant for satisfactory operation. V1 and F should vary proportionally. This is very important point. So never vary. So never reduce only frequency by keeping V1 constant. For satisfactory operation, V1 and frequency should be varied proportionately. So if we are not varying supply voltage, obviously we are going to get the deep saturated core. This is about the important observations of induced EMF or important observation regarding EMF equation and the magnitude of EMF equation. Thank you.